Okay, now we're going to find the gradient when we have a line that's on a grid here. Okay, so where's the triangle gone? Now the first thing we're being asked to do here is to name our line here. It's passing through the points A and B. Okay, so we could call this line AB. Okay. So actually, when we're doing the gradient, this is something that you might come across when you're doing higher. Where it says M here, we just write the gradient of the line AB equals height over horizontal. Okay, now it's handy that we've been given two coordinates here, okay, because they're going to help us to see a triangle. Okay, so I see one here that goes along the way and up the way like this. Okay, so I can see, if you count the boxes, 1, 2, 3 spaces along the way, so the horizontal distance is 3, and going up the way, count the spaces, 1, 2, 3, 4 spaces going up the way. So for this one here, the gradient is 4 over 3. Remember to leave that as a fraction. Please don't change it to a mixed number, just leave it there. Okay, and now we have another example. This time we've got a line. Oh, right, we've got to be careful with this one. This is the first one where we've seen a line that if we start from the left hand side, this line is going down the way. So I'm just going to have a little bit of a think already. I'm going to put in that I know my gradient is going to be a negative answer. Okay, all right, tidy that up. Okay, so that's something I spotted. That was close. Right, so what are we being asked to do? Name the line. We've got two letters here, CD. Okay, so I always put them in alphabetical order. So I would say the name of this line is CD. You could call it DC as well. Okay, the other one I called it AB again, just habit to put in alphabetical order, but I could call that BA as well. Okay, right, so we've been given 2 points. Okay, we've been given this one here, and we've been given this one down here. Alright, so again, that's really handy for working out our gradient, because I'll just use the grid lines to get a triangle. Okay, so what have I done this time? 1, 2, 3, 4. That's my height that I'm doing there, isn't it? Okay, so I'm counting the spaces. So the height is 4. And how far across the way is it? And then it goes 2 across the way. Okay, now you might notice that's not the only way that I could have made a triangle between C and D. I could have gone along that way and down that way as well. But it doesn't matter, because if you look at how many I've gone along the way, I've still gone along by 2. Okay, so the horizontal distance is still 2, and then the yellow line going up and down the way, still got 1, 2, 3, 4. So the triangle still has a height of 4. Okay, and the same on the first diagram as well. I could have done my triangle going on that side there, but it doesn't matter. If I think about the along the way bit, 1, 2, 3, that was what I had for the horizontal before, and up and down the way here, 1, 2, 3, 4, I've still got a height of 4. Okay, so don't worry if you saw the triangle the other way around from me. And one more thing to think about is that because the line is going between C and D, we can name the gradient a little bit more thoroughly. Wrong pen. We can call our gradient the gradient between C and D, like that. Okay. Now I also need to simplify down my fraction here. Oops, wrong pen again. I need to simplify down my fraction here. I've got a minus answer. And if you look again, thinking about this as being a divide sign, can you do 4 divided by 2? You can indeed. 4 divided by 2 gives us 2. So the gradient for our slope here is -2. Okay, so we have to calculate the gradient again. Now, we still have a line that's on a graph, but the grid lines have gone missing this time, but it's really not a problem. Okay, remember the coordinates always start from this point here, where the x and the y coordinates cross over. The x and the y axes, sorry, cross over. This point here is known as 0, 0, but it also has a special name, the origin. Okay, so if we're going from the origin to the point 0, 2, we would go from there to there. All we would do along the x-axis nothing and up 2. Now that's the first number that we need to help us to calculate our gradient. The other coordinate that we've got here is -4, 0. So that means go along to -4 and up nothing. Okay, now how far is that? Okay, think about that distance. We went along from 0 to -4. The distance is 4. You might be dying to say it's -4, but it's not. Think about it, right? A distance, it would just be 4. Okay, so what have we got for the height? 2. And what have we got for our horizontal distance? We've got a horizontal distance of 4. Okay, now I've written that as a positive gradient. Okay, let's just check that. If I start from the left-hand side, the line is going up if we start at the left-hand side. Now, one more thing to check. Can I simplify that fraction at all? Can I do 2 divided by 4? Nope. All right, so I'm going to look to see if I can simplify. 2 times 1. 2 goes into 2 and 2 goes into 4. Okay, divide it by 2, you get 1. Divide it by 2 and you get 1 there. So for the top, 1 times 1. For the bottom, 1 times 2. And we've got our gradient of 1/2 there. Okay, one more example like this. If we start from the origin again, okay, remember that's where the x and the y-axis cross over. To get to the point 0, 5, we move along nothing and up 5. So that means that we have got a height of 5. And if we look at this next coordinate, -3, 0, we would start at the origin and go back to -3 and then up nothing. Okay, so remember, that's got a distance of 3. Okay, so what did I have for my height? Down to my formula. I've got a height of 5 and I've got a horizontal distance of 3. And that one doesn't simplify. And one last thing to check is to see whether or not it's a positive or a negative gradient. So I'm going to start round about here on the left hand side and it's going up. So I am right enough to leave it as a positive gradient.